So in this short video, I'm going to respond to a WhatsApp question that was asking about the forces that are found on the inclined plane. So when you have a box or an object lying on an inclined plane as shown there, so these are the forces that are present. You have your force of gravity acting in that direction. You also have your normal force. You also have your frictional force, which is holding the box in place. And so if you put your axis, this is what you realize, that you can break down your gravity into its horizontal and vertical components. And you see that the vertical component there is acting parallel to our axis there. So when we do our trigonometry, we can find that we already know that our force of gravity is equal to mg, and we have an angle theta there, which is similar to the angle that we are given, or the angle of inclination. If you tilted your axis like that, you would also realize that those components of gravity, the vertical and the horizontal components, are acting parallel to the x-axis and also to the y-axis. So those are the forces that are available at the end of the day. Putting them together, you realize that we have the gravitational force balancing out with the normal force, and the frictional force balancing out with the other component, the horizontal component of our gravitational force. So that being said, we know that through trigonometry, our mg cos theta is equal to that component, and our mg sin theta is equal to that component, because we have a right angle triangle there. And we know that these forces are balancing out. So our normal force is going to balance out with our mg cos theta. So let's look at a specific example where we can apply this. 10 kg box is on a 30-degree ramp. What is the force of friction that keeps it in place? So those are the forces that are acting on the box, and we can resolve there by saying 90 our gravitational field strength times our mass. We get our 98.1 for the force of gravity there. So we have our angle sin theta, which is equal to the angle of incline, and we can resolve there for the vertical and horizontal components by trigonometry to get 89 and 49. So you know that the frictional force is going to balance out with the 49 Newton force there, and our normal force is going to balance out with the 85 Newton force there. So the force that we are looking for is 49 Newtons, which is equal to the horizontal component of our gravitational force. So remember that these forces balance out and they give you a 0. So we have plus 49 minus 49 for the friction there. So the answer is 49.